Problem 6, another similarity proof. And whenever you have this hourglass shape, all right, right, your mind should immediately jump to vertical angles. That's something you know. That's something you can access. I can say this angle must be congruent to this angle. And if I'm going to use this in my proof, I'm probably going to use the sides that form that angle. Um, and because the Regions has an objective to either trap you or assess how much you know, um, I'm going to get rid of that 24 because I don't have the corresponding side in my other triangle. It's just not a piece of information I know. And that's the trap. They're hoping I use 24 in one of my ratios of sides. Um, but I'm not going to fall for it. So I'm going to do myself a favor, cross it out. I don't need that side because I can already see the angles I'm going to use are angle VJU. That's this angle down here. And that must be congruent to angle KJL. I know that because vertical angles. And it's as simple as that. Um, so I've got my first fact, which is an angle, and I know I have to use, in order to use side angle side, which I'm going to use because I have an angle here, I know that the sides I need to trap that angle. They need to form that angle. So I'm definitely going to use this side, JU, and that's going to correspond to side KJ. KJ, right? JK, JU. So that's 14, 49. I'll check that later. And then I'm definitely going to use this side down here, VJ and JL, right? First and last, and first and last. And that's going to be, I just got to pay attention. I'm starting here with the small numbers, right? I'm starting with that small triangle and dividing it by the corresponding big. So that's kind of why we write out these names, is I can go, oh, VJ is 22 and JL is 77. And I'm going to use my calculator. I know when I type these in, whatever it is, those ratios, those comparison of sides with division must be equivalent, because that's how you can show sides are proportional, that they grow at the same rate. This weird 0.285 blah, 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 blah. And when I type in 22 over 77, I know it's got to be the same. I know it. So uh, I think you can just, honestly, you don't have to write out the decimal. You know what? It's not going to hurt. You can write out the decimal. You can leave it as 14 over 49 and 22 over 77, or maybe we should do some math, turn our answer into a fraction, and you could write the reduced fractions, 2/7. This 14 over 49 is really 2/7. That 22 over 77 is 2/7. And that's how I know the ratios are equal. So I'll leave it like that. I'll do it like that. You could write it in decimal form, 0.285, 0.285, or the way I've written it. And let's go ahead and write up our second statement, that I've got this comparison of sides with a ratio. I'm going to erase that. Why'd I do that? Well, that's a ratio of corresponding sides. It's a side. My third fact will be this comparison of sides. Why did I do that? What's my reason? Well, that would be I'm just making a ratio of corresponding sides. So when I go to make my final claim that these triangles are similar, I can say that because of the side angle side similarity statement theorem, which says, look, if you've got proportional sides, sides with equal ratios, and if you have a pair of congruent angles in between those proportional sides, well then those triangles must be similar.